Welcome everyone to this week's installation or delivery of the Ekahau webinar series. We'll be talking about Wi-Fi network life cycles 101, right? So this is kind of an introduction, setting the framework for how you can manage or progress through your Wi-Fi network life cycles. We're not going super in depth in this. It's not a 408 level class or anything like this or a session, but we'll be covering a lot of the highlights, right? And so to jump into the show, let's get on with the introductions.
Yeah, we've got the right people here for sure, especially with Vlad joining us today. He's going to be talking us about some of the newest things available in Ekahau AI Pro Online. I think that's kind of what you're looking after now, right, Vlad? AI Pro Online and all of our cloud applications kind of falling underneath your roof now.
Yes, that's absolutely the case. So I'm basically looking after all Ekahau cloud products at this point. So welcome everybody.
Yeah, and I believe towards the end of the webinar, you've got a really nice live demo lined up for everybody to take you through how you can leverage some of our new reporting functionality.
Yes, we are going without capes, so we're using live demos nowadays. We are so certain. Everything's super stable.
Perfect. And then you've got myself and Troy. We both look after product marketing and ECSE here at Ekahau. We have Stu, who's going to be in the chat talking to you and answering some of your questions. And in the Q&A, he's responsible for our community. And also we've got Dale, who's going to be in there helping out as well and looking after our amazing sales engineer team. So jumping into the webinar today then, what is Ekahau's guide to having a great Wi-Fi network? Well, from our perspective, we can't highlight and recommend this enough how important it is to go on site and collect data about your environment. Going on site and understanding how, if you're going to be designing, even if it's a completely new network from scratch, it's still really important to go on site and understand the materials that you're going to have, attenuation of certain objects, where you can't mount access points. Having a look at just a floor plan in 2D doesn't necessarily give you the full understanding or full picture of what you actually will want to do with that space when it comes to designing your Wi-Fi network. Also, if you have an existing Wi-Fi network there, we can leverage so much of that data to help you with your design, understand if you have any interferers. Perhaps you need to avoid using some certain channels in your environment because it's heavily congested. And also, it's just a really good way to get a feel for your design. And then once you've got that data, you can then take that back to your project. You can start designing your new network or do an upgrade to an existing network. Or maybe you just need to tweak a few things like move an access point here, move an access point there, install an additional access point to kind of meet some additional coverage requirements or some capacity requirements that you might have. And once you've finished doing your design, you've provided that to the installation team, it's really key and important that you go back and you validate your design. I can't emphasize enough how important that is, and the difference sometimes from what you believe from the access point icons that you put on a map and you provide to someone to go and install and deploy to how they configure it, sometimes that can completely be different to how you've actually designed your network. So going back, validating it is a real great way to make sure that the way that the installation and the configuration actually matches what you've designed for the network. So then the Wi-Fi is going to work really well. And actually, we're going to kick off a poll question quite early on in the webinar series today, Troy.
Yeah, so to get us thinking about this, just think about your Wi-Fi life cycles for your projects. And if you guys want to answer one of these four choices, as you go through the life cycles of your projects, right? Do you have a life cycle where you just deploy your wireless access points, and if you run into issues, do you just swap them out with a new vendor's platform, hoping that that'll fix everything? Or do you have more of a structured approach? You follow the four-step process of defining, organizing, planning, and then executing on all that work, right? Or do you subscribe to the 4D model, right? Where you define, design, deploy, and diagnose your Wi-Fi life cycles, right? Or are you just stuck in last century's Wi-Fi where you deployed 802.11 prime, and because Wi-Fi is inherently backwards compatible, you've never had to worry about lifecycle management because it's always been working. So just let us know your thoughts there. Which lifecycle model you guys use as part of your successful project implementations?
Yep, I can see pretty much around half of you have had the chance to vote. So we'll just give it a few more seconds and we'll go ahead and end the poll and then share the results with you. Uh, I kept wondering why you was calling me dope so much whilst go putting this webinar together, Troy. Now it's kind of making sense.
Well, it's an absolute compliment, right? When you put together a great life cycle or a brilliant Wi-Fi designer like yourself, you have a pretty dope looking Wi-Fi solution.
Yeah, I like it. It's all making sense now. All right, let me end the poll and then share the results. So, what do you think about those results, Troy? Anything that stands out or surprises you there?
So I'm sure it makes some sales guys happy that some people like to switch vendors as part of their life cycle management, right? Always a good excuse to sell some new products. But it's interesting that the two in the middle, the two four-step processes, were heavily voted on by a lot of people. So
Hmm.
maybe we'll dive deeper into the four-step process and see which one that we're going to be promoting in today's call. Right. So in fact, we're going to be looking at the 4D model, right, which is an industry standard. We like to leverage the D's as part of this to help people remember the different steps. We are going to break these down in detail. Matt and myself will walk through each of these four steps to provide some more insight about considerations, things you should be looking for, some tips and best practices as we go through each of these four steps. But this model here, the define, design, deploy, and diagnose, this is the recommended lifecycle management that you should be imploring when you walk through your solutions and your projects.
Absolutely. So let's start with the define process because this is really important. No two environments are the same. No two offices are the exact same. No two hospitals, no two warehouses. Each and every one can have their own unique qualities or the way that they want the Wi-Fi to work. So it's really important before you start the process of going on site, doing a survey, putting APs on a map is that you speak with the stakeholder, you speak with the customer to understand what is it they're actually looking to get from that Wi-Fi network. Is it simply just providing some coverage for guests to get on board with? Is it providing high density, completely redundant office environment space where they need to have all Wi-Fi first? Or is it a hospital that needs to do asset management tracking through the Wi-Fi network or some of the technologies inside of those access points? Because understanding and asking those questions can really change the output of your Wi-Fi design that you go ahead and do. And it's important, I really think it's important that you speak to many different stakeholders or people at the environment. So you have a perception from some people from when you speak to maybe the not so technical guys or girls from the environment where you want to sit down and understand the business requirements. So speak to the stakeholders. What is the desired outcome of this network? Maybe ask them what are some of the challenges that they're currently facing with their Wi-Fi? Why have they reached out to you to help you to, to get you to help them with their new Wi-Fi upgrade or new design? Find out some of those challenges and what is the desired outcome for the business purpose of that Wi-Fi network. And typically that's going to probably be someone who's a little bit more senior. Maybe they own the company, maybe they're the IT manager, maybe they're the CEO. You have this kind of conversation with them. What is it that they're looking to get from the Wi-Fi network? So you've got that understanding. And then you're going to have a conversation with probably someone who's more of the engineer or technical capabilities where you can have the conversation with them. Okay, so this is the desired outcome that you want to have a voice over Wi-Fi network for your office that's fully redundant, etc., etc. Are there a specific AP manufacturer that you need to work with? If we're going to design for a warehouse, we want to use some directional antennas. Is there a specific vendor that you want to work with or can't work with? Then you really need to define in scope and out of scope areas where you want the Wi-Fi to maybe some areas that are not so important. I think the one of the most famous things you hear when you go through this process, speaking to people to find their requirements, and you ask them, "Hey Troy, where do you want the Wi-Fi?"
Well, I need it to work in the washroom.
Yeah, typically most people turn around and say, "Yeah, I need Wi-Fi everywhere." And you go, "Okay, fine. So I'm going to put it in the stairwells, in the plant room, in the top bathrooms, outside, in the manufacturing bits and places, everywhere." And it's going to mean you're going to need X amount more access points. You're okay, hold on a second. Maybe we can scale that back a little bit now. I don't quite need Wi-Fi in the car park and here and everywhere. But then sometimes people might say to you, "Yeah, I do need Wi-Fi in the washrooms or in the stairwells." And it's good for you to understand that because those locations might be a bit trickier, especially for running cables into those locations because they might be brick or concrete or you've got to try and figure out how you're going to get the cable there and the access point. So it can be a bit more tricky. I'm currently in the UK and Troy's in Canada. You might engage somebody, and when you're having the conversation, be in the same region as them. But what they might be actually asking of you is to design a Wi-Fi network in one of their other sites that maybe might be in Canada. And why that's important is because the different region that you're designing for can mean that you have to use different channels, different transmitting power levels, different to where you are currently. So making sure you understand that and then factor that into your design is also important. And once you've gathered all of these requirements, you can then convert them into RF requirements. So I've taken all this information from the stakeholders, from the technical guys or girls on site, and now I understand like how I'm going to be designing the Wi-Fi network to a certain set of parameters. And what that typically means is we're going to be taking that information that we've been told, we are going to be then translating what the customer requirements are into some Wi-Fi requirements. And you might end up documenting it in a table that looks something a little bit like this, Troy.
Yeah, so often we get the requests from customers when you ask them, what do you want your Wi-Fi to be like? Do you want NIC 67, NIC 75, NIC 62? And you just spew out numbers, and they're like, I don't know what you're talking about. I just want the Wi-Fi to be good, right? And this is where you show off your expertise and you play the role of that trusted advisor, that consultant, and you have to translate when the customer asks for, hey, I want the Wi-Fi to be good. What does that translate into numbers that not only can you design to, but you can also validate against, right? So you end up with the table here, just an example of some of the values that you could design your network to. Um, Based on the requirements that you've gathered, conversing with your stakeholders and identifying the type of devices that would be connecting to the network, you can figure out what signal strength you need on different bands, right? So identifying your primary and secondary coverage, and they don't have to be the same RSSI value, right? It just depends on what your targets are for roaming, hardware redundancy, capacity, the amount of throughput. You also want to identify the types of devices connecting to your network, what those capabilities are. Do they support Wi-Fi 4, 5, 6E, Wi-Fi 7, and how many of those devices will be in different areas? So once you've put together this table, then you can start looking at your design. Now, if we transition from a table like this is what it would look like entering that same information into Ekahau AI Pro Online, where we can define our coverage requirements. We have the ability to customize the types of devices and the number of devices that we can find in different areas across our floor plan. And then we can evaluate all these metrics to determine whether we have met those conditions as part of our design, right? Or we have to revisit and optimize our design to keep tweaking it. So this brings us to our next poll question, right? And this is now that you've put together your design, one of the questions that comes up is how do you define which Wi-Fi design is the best? Right? And some people are just extremely confident in their designs, right? Whatever their design is, it's always the best, no matter what. There's no point of even questioning it. You can also make salespeople happy, right? Whatever design requires the most number of APs. I was just recently working with a customer. They're very interested in location tracking, and they said, why don't we just put in an AP every 2 meters? Right? They mentioned this in front of the account manager, whose eyes immediately lit up. That was their one takeaway, I think, from the entire day. Or you could leverage the power of AI Pro, the AI auto planner, and let it quickly design and place APs for you on the map, right? Following some best practices, you can quickly generate a design, produce a bill of material, deliver a quote from that, right? Or maybe think a little bit more philosophically about the question. Whatever design you put together that leverages the fewest number of access points while still meeting all of the design requirements, right? So what Matt had talked to before about gathering all the requirements, having conversations with stakeholders, spending a lot of time up front identifying all those requirements, right? And there's part of an art to that to make sure that you've listed all the design requirements. But if you can meet all those requirements, whatever design has the fewest number of access points is probably the win for both you and for that end customer or client or your particular deployment.
Yeah, I really like the results of this poll question. I mean, two are particularly favored on this, and I would say around AI Autoplan, it can be a really good start for you to get an idea of how many access points you're going to need for coverage and capacity. But you should still make sure you tweak things and make sure you can actually where Autoplanners put access points are actually in places where you can physically install them and validate them. Make sure that that is going to be right for your design. So very interesting results there. And let me stop sharing.
Yeah, so the next phase of the Wi-Fi network lifecycle is the design phase, right? And to go through the design phase, we have a lot of different options that you can take while using Ekahau's suite of products. And a lot of it is related to the type of design that you're trying to put forward, right? So there's a lot of different scenarios. You could have a scenario where the building has not yet been constructed, right? They still haven't flipped over any soil, they haven't poured any concrete. There's no option to go on site, measure any wall attenuation or anything like that. And for those particular situations, that's where following a traditional predictive model would be a good fit, right? You're adding the floor plans, you're drawing simulated walls, and of course, adding your simulated access points. You're making best guesses about what the wall attenuation is for various materials, knowing that there could be some risk, right? That you may not be modeling with the actual attenuation of that wall material. But because that building doesn't exist yet, there's no way to validate that, right? And Ekahau does have a whole bunch of typical materials that you can select from, as well as the ability to customize those materials based on your experience and insight, or if there's any extra details in the AutoCAD diagrams indicating that some materials are, double, triple ply drywall, if they have insulation in the drywall, if it's wood, metal, studs inside those walls, right? So that's one option. Another option is if you're doing a technology refresh, right? So it's the existing building that already has a Wi-Fi deployment. You're looking at migrating to a new Wi-Fi technology. We have a completely new set of design requirements. Back in 2012, they were just looking for basic Wi-Fi opportunistic coverage. Today, we're looking for a voice grade design because they want to be able to walk around on voice handsets, talk to their maintenance teams, service teams, so they can do some building repairs, that kind of thing. If you have a site that has existing Wi-Fi, you can walk around with your Sidekick 2, follow your best practices for performing a site survey, walk everywhere that's in scope, make sure you walk on both sides of the walls, make sure that your distance between data points is close enough. You can upload all that collected data to AI Pro Online, and leveraging some artificial intelligence and machine learning algorithms, we can then model what the RF environment for that site looks like. And this way, you don't have to spend a whole bunch of time drawing walls, making best guesses about what that wall material is. Ekahau will model that attenuation for you, and now you just have to worry about placing APs in the ideal locations to deliver on the requirements that you're aiming for. Right, so we have that. Also, once you've operationalized your network, another option is while you leverage your vendor's auto RF algorithms for changing channels, changing power settings, right? Once those changes kick in, you can leverage some API calls to those vendor platforms, pull out the transit power settings, the channel settings, and then visualize that in Ekahau to see if those auto RF algorithms are making some good choices and what the impact is to your design. And so you can continually optimize, tweak, and tune things, right? Or there's a last option where you can just simply walk around with your Sidekick 2, right? Collect and measure the data and then visualize signals as measured, as recorded by the Sidekick 2, right? So many different options that you can use for your design process to get the best coverage and find the excuse me the right number of access points that you need to hit all of those defined design requirements.
Yes, and then once you've done your design, we then move into the deployment phase. And the deployment phase is critical and key that we get this right and understand some of the things that can potentially go wrong here. And if we just take a look at some of the antenna characteristics to think about when you're not just thinking about external antennas, but even the access points that have integrated omni or directional antennas, we're thinking about, how are we going to be using this? How is it going to be installed? What direction does it need to be installed? It's crazy. Some of the access points now that are available, even with quite directional integrated antennas, they look just like normal omnidirectional access points. So the way that you get the access point physically installed, especially if it's got directional antenna, can have a big play on how the Wi-Fi is going to perform. If they install it incorrectly, you're going to get a completely different polarization and propagation coming from that access point antenna that you had planned for. And also thinking about how you're going to physically install some of these access points. I know in central London, there's so many of these offices now that have completely exposed ceilings. And what I mean by that is that there's no more of those like false ceiling tiles that you can kind of grid style that you would see before. Everything is exposed. So you see the air conditioning, you see the piping, conduit, you see everything that's on the ceiling. And when you provide a floor plan to the installation team and you give some API icons on a map, if you don't provide a good level of detail of how you physically want that to be installed. I've seen installers literally just go take an access point, put it right up on the actual physical ceiling, and it'd be completely surrounded by all of this different metal and steel and other pieces of concrete, and that can attenuate and corrupt the signals coming from the access points straight away. So it's really important when you're providing this information to your installation team or whoever's going to be doing the deployment for you, that we maybe provide a bit more context and help people along the way and understand a little bit more of like just seeing these dots on a map. So I've seen a really nice couple of examples in some reports recently where they are providing more context and some visual aids to be able to see the access points and the mounting solutions. And if you're going to be including some of the antennas in the design and deployment, but not only that, also adding some additional context around like a best practice for a general installation guide. That if the ceiling height is above a certain height and we're going to be using access points that have integrated omnidirectional antennas, we're going to then suspend that down via a pole so it's not too far away from our client devices. And in the same vein, if the ceiling height is for whatever reason 2 meters or lower here, then we're not going to put an AP in this position. So add a little bit more context to your reports to give to the installation team can really help them. And then finally, another really nice example that I saw someone recently do is making sure that the access points are installed away from other objects. Again, because when you're just providing icons on a map, sometimes you don't know if there's going to be a fire sign, a sprinkler system, some lighting, and other bits of material in and around in the environment. And the installation team don't necessarily understand that maybe they shouldn't be installing right next to these other devices that could potentially cause us some interference or problems with the signals coming from the access points. So it's just a nice way to be able to give a bit more context to the team to make sure that your deployment is actually what you intended it to be. The other key thing around those 4Ds that we're talking about is once you've done your design, you provided it to whoever's going to be installing it, is then making sure that the network is configured in a way that correlates with your design. And we've got some general kind of tips here for your Wi-Fi configuration. So when it comes to your transmit power levels, typically we're going to be using a kind of range in between 11 to 17 dBm. But again, this has some caveats because you might be using some access points that have high gain antennas that could be increasing your EIRP, and you need to keep that within your regulatory domain limits. But I would say as a kind of like rule of thumb, using a range between 11 to 17 is typically what we see a lot. Data rates, I think most people here probably use 12 or 24 megabits per second as the minimum basic rate for your configuration of your networks. Sometimes you might go lower if you need to support some of these older devices, but we're talking pretty old devices now. And then sometimes you might go a little bit higher, but as a kind of rule of thumb, this works pretty well. Then when it comes to your channel widths, I know a lot of people will always say, you know, especially on 5 and 6 gigahertz, use the widest channel you can until you can't. And what we mean by that is if you can get away with using really wide channels and not cause yourself channel interference on your network, and you haven't got too many other networks around you causing you interference, then there's no harm, no foul by going with really wide channels. However, if you're using really wide channels and you've got a whole bunch of co-channel interference and contention, then you're probably going to be causing yourself a whole bunch of problems. So it's better to go to narrower channels. Now, this is why it's always important to go on site, survey, validate, measure, understand what you can actually do. But on 2.4 gigahertz, if you are using that band still, then always stick to 20 megahertz, pretty much 9.999 times out of 10. Then when it comes to your channel plan, I would say in most scenarios, it's probably absolutely fine to use your AP vendor's algorithm for radio management. You want it to be making changes to avoid channels and pick the best channel to not have as much contention. However, there may be some environments that you decide, you know what, I want to have full control over what channels that I'm going to be using. And I know 100% this isn't going to cause me any contention on my own access points. Maybe it's something like a football stadium, auditoriums, other environments, maybe even a warehouse where you want to go with static channel planning, where you know exactly the channels that you're using and you're confident that that plan isn't going to cause you any issues. And finally, roaming configuration. We always want our devices not only to be able to connect and get on fast, but also moving around and transitioning through your environments. You want them to move between the access points fast too. So a couple of things we always pretty much recommend having on is 11K neighbor reports. Access points can inform client devices of its next best neighbors to go and associate to. So when it comes to scanning and finding another access point to go and roam to, it doesn't have to go through all of the Wi-Fi channels to find another access point. And if you're using any SSIDs that are configured with 802.1x radius authentication, always try to enable something called 802.11r fast transition, because that will heavily increase the roaming speed for radius authentication SSIDs. And there is a slight caveat there because maybe not all of your client devices support 11R. I'm sure most of them do. Again, test it, but you definitely want to have this enabled as if you can, if possible, because it will make it a lot quicker to roam between access points, especially if you're using any that have radius authenticated set up on the SSID. My little final kind of bonus tip here is make sure that your Wi-Fi design and configuration are in sync. I can't tell you the amount of times that I've seen a Wi-Fi design performed in Ekahau, and then you go and validate or you go look at the network and you're like, hold on a second, this looks totally different. And people can't understand why does it look so different? Because you've designed in Ekahau to use a certain transmit power, certain channels, and then your configuration from the vendor or whoever's deployed it is completely different transmit power, completely different channel widths and channels that are in use. And even though the APs are in the same position that you recommend in your design, the actual output of the network will be completely different to what you design for. So once you've done your Wi-Fi design, it's really important to make sure that your configuration is in line with it. Otherwise, your expectations of how it's going to be could be completely different. And I think that moves us on to the next D, Troy.
Yeah, so once you've validated your design and now you're in production, over time, the RF conditions may change, the user requirements may change, the types of devices or applications that are being used, those continue to evolve. So it's very important that you do some regular diagnosis of your network, which is essentially troubleshooting, right? So there's a book that's soon to be published that you may be able to order, talking about why the Wi-Fi is down and letting you know all the reasons for that. And again, typically it's not the Wi-Fi itself that's actually down. It's something peripheral to Wi-Fi. So often upper layer protocols, DHCP, DNS is a classic issue, captive web portals, radius servers could be broken, out of service, unreachable, lots of those different things, right? So stay tuned for that book to be published by O'Reilly Press. With respect to troubleshooting, there's two different ways that we can look at this. One is proactive, which I think is the ideal case, and that's where we're able to identify issues and problems that could be occurring on your Wi-Fi network before it becomes impactful to your customers, right? So this allows you to mediate that action, reduce the number of trouble tickets that are coming in. And a lot of this comes from regular, routine, automated testing of your network, right? So you could have, humans walking around on a weekly basis, all carrying Sidekick 2s, doing surveys. Honestly, though, I have yet to run into a customer that can justify a weekly site survey with a human. But that's why we have robots, right? So if we can contract out or offload that to Roombas driving around on a nightly basis, having robots in your warehouse that, in addition to moving boxes and inventory around, they could potentially also be doing site surveys, collecting that data that gives you a lot of insight from the client perspective into what's happening on your wireless network, and you can be more proactive in identifying issues before it becomes a big burden to your users. Where we are typically today is we're reacting to issues that are coming in, right? We're right on the cusp of making this transition. Here, users are opening up trouble tickets, opening up cases saying, hey, I can't connect in this office, or, I brought in my device, Wi-Fi is not working, it's slow, I can't get access to this application. And then we have to troubleshoot what's going on in that specific location, looking at commonalities across issues. Is it just one user, one device? Is it everybody in the same area connecting to the same access point? Everyone on the same floor? Everyone in the same building? Everyone going back to the same controller or authenticating against the same radius server, right? So, what are common points between all the issues that we're encountering and trying to resolve that, right? And there is a methodology that we can look to try finger points to what could be the root cause of that issue. And we do have a 9-step process to make that happen.
Yeah, I mean there's a lot of things that could be causing us issues with our Wi-Fi. But before I jump into these, I've just noticed in the Q&A there's a few questions that we wanted to answer live, and I feel like since we've been talking around channels and things like that, maybe it's a good time we can interject with a couple of these questions. So someone did ask around when they do a channel plan, they do even a quite a simple one, they're preparing in a predictive report, the APs are selected with some channels in the design. But then when it gets implemented, the access points and the vendor controller automatically assigns different channels. Is that good practice? I would say that that's completely fine and as expected. What I would say I'm looking for when I'm doing my design and with a channel plan is to ensure that my network that I've designed isn't going to be causing channel interference on itself. So based on the amount of access points that I've got, based on which frequency band I'm using, and based on what channel width I'm trying to use. Maybe let's say I'm using 20 access points, I can get away with on 5 gigahertz using 20 megahertz wide channels and not have any CCI. However, if I have a 20 AP deployment that can all hear, or at least 20 access points that can hear themselves, and I'm using 80 megahertz wide channels, I would then know that I'm going to cause a whole bunch of contention on my own network. I don't really want to use 80 megahertz wide channels. And I would say it's completely common and normal for you to come up with a plan and design using Ekahau software, and then whatever AP manufacturer vendor that you're using to deploy the access points, the controller is going to the controller and the access point is going to learn about the environment, dynamically change channels to try and pick the best ones for the environment, listen to your neighbor's access points, try and avoid them as much as possible. So that's completely normal and expected kind of behavior. If you do want to have a bit more granularity and control and very much want to know that the plan that you've come up with a static channel plan, you know that's not going to cause any CCI, you can implement that in your controller based on what you've done in your design. That's completely fine as well. And then another question just before we move on was around, is it okay to use 20 megahertz channel bandwidth in 6 gigahertz in a high density environment, especially when you have limited number of channels available in regions like the UAE, where you have a limited number of non-overlapping channels? I would say it's completely fine to use 20 megahertz wide channels on five and your 6 gigahertz deployment, especially if you've got high density and you've got a lot of access points around you. I think it's better to have as much of a contention-free network as possible rather than trying to achieve super high data rates. Because even on a 20 megahertz wide channel, where you've got a client device that can do 2 spatial streams, even on a 20 megahertz wide channel, the data rate between the client device and the access point, you're looking at, there's some variables here, but in and around 200 megabits per second. Some's going to be about maybe about 150, 170, going pushing up to close to 200 megabits per second, even on a 20 megahertz wide channel. And for most applications and the bandwidth that the device is going to need, that's going to be more than enough. The only reason that you may want to go to wider channels in some environments is and have those faster data rates is if you've got to transfer a lot of data. Maybe you're working on big projects and sending big files, then that could be a reason why you want to go for those wider channels. But I think just to answer those questions really quickly, totally fine for your design to have what one set of access your access points have one set of channels, and then your deployment to be something else. As long as you have a nice contention-free network, that's the best. And also when you're doing your design, using 20 megahertz wide channels is completely fine on 5 and 6 gigahertz. So what we're looking at here is some of the potential common reasons why you may have issues on your Wi-Fi network. Far too many for us to drill down deep on this webinar today, but we do have a whole training course dedicated to troubleshooting Wi-Fi networks, and it might be not just one of these 9 reasons, it could be a combination of a few of them causing you issues on your network. So if you're really interested in Wi-Fi troubleshooting and understand a bit more, then I highly recommend you check out our ECSE troubleshooting course, and then you'll be able to understand all of these different fails at a much deeper level. So I'm just going to move on to the next slide for you, Troy.
Yeah, so to summarize, we have the 4Ds as part of a good network lifecycle design process. But in addition to this, something that you should be considering is at each one of those 4 steps, you want to validate the information that you've collected, right? So when you're defining the requirements and you ask, where do you need coverage? And the customer says, we need coverage everywhere. Okay, well, if you say everywhere, does that mean that you want to put an AP in the washroom? If you have to pay for the cost of that, is that in scope? Will you pay for the conduit, the wiring, the cabling, and AP to be installed in the washroom? Like, no, that's silly. Why would I put an AP in the washroom? Well, you said you needed coverage everywhere. If you need APs in the stairwells, that's extra cost. So I like to tie that back to a price point, a financial decision, right? If you said it's in scope and we need to put an AP in that location, you're willing to pay for that extra installation cost as kind of a double check to validate that, right? Matt also talked about the deployment, right? Once you've deployed your network, you want to validate to make sure that your deployment matches your design scenarios. And then framing all of this together, it's super important that you communicate everything that you've heard, echo it back to your audience, to your clients, to your customers. This is what I heard you say. Is that what you meant? Right? Double check that what they're asking for is truly what they're looking for in the design, right? We also want to think about communicating our design, our deployments, our requirements that we've gathered. We want to communicate them back to stakeholders and documents so that we can audit that later and say, hey, this is what we designed for, and it met these targets. You said voice was out of scope, so we didn't design a network capable of voice applications. And now you're complaining that it doesn't work. 6 months ago, we agreed it was out of scope, right? If you wanted a voice grade design, we could have designed that, but you didn't want to spend the money, right? So make sure you document things like that, right? Sort of covering yourself, right? Now, as part of all this communication, right, that brings us into report telling, right? I want to focus on just the communication part of things, the art of storytelling, right? So as we put together our reports, right, it may be sad to hear, and maybe some of you are paid based on the number of pages that you put together in your report. A 500-page report sounds like a good value for your dollar, but it may not have a lot of worthwhile content, right? It's just a bunch of data that doesn't mean anything. So as you put together reports, you want to think about tuning them or customizing them to the audience that's going to be consuming that document, right? So if you're generating an installation report, you want to include those details that are relevant to the installers. They don't need to see all of your heat maps, your bill of materials, but they do need to know where the APs need to be positioned on the map, the height of those access points. If you're using external direction and directional antennas, you want to document the orientation or the angle or tilt of those antennas. Any special brackets or considerations that they need to be aware of when they're mounting those APs, right? So what we're going to jump into next is Vlad is going to give you a demo of how we can create these tuned and customized reports that are geared to specific audiences. So I'll hand it over to Vlad now to walk us through these report templates.
Thank you, Troy. So it's demo time, right? But before we jump into the actual demos, I will just want to highlight some of the principles that we aim at Ekahau. So we want to make the reports and creating custom reports as simple as possible and as user-friendly as possible. So there are 3 basic steps. First, you define your report structure. Then you define your report components for these elements you have in your report. And the final step is the report generation. But the topics that I will be covering in the demo are basically, if you haven't been using the custom reporting yet, because it's very fresh from the oven. It has been released only a couple of weeks ago to AI Pro Online. So I hope this demo will help you get started with this feature. So we will be creating our first custom report out of this feature. And then we will check the default custom report templates, which are serving this 4D model for each of the Ds. And finally, we can check what can you do actually with the custom report templates, how you can share them with your peers, how you can save them, copy them, etc. So without further ado, let's jump to the demo. If you are new to Ekahau or haven't been using our online tools, I strongly recommend you, if you have a Connect license, log in and please try out and use AI Pro Online. That's our greatest and newest tool for Wi-Fi planning. And I have a sample project here, which is based on the survey. So here I have my survey project uploaded to the cloud, and I open it in AI Pro Online view mode. So I'm not able to edit it or anything. I'm just analyzing data. This is my original data, primary signal strength. That's how it looks. And now what I'm doing, I want to create a predictive design. So basically an improvement to this network, right? And I have already done some changes. Here it is. I have added some additional APs. And as Troy and Matt were maybe showing in the presentation, is that we are now using measured data and AI ML environment to predict how your network will look when you make those changes. So you are not drawing any walls, you are just making the changes. So here, for example, I have moved some access points around, you see. So I have made my predictive design changes. But this demo is not about designing, it's about reporting. So where you can find the custom reporting, it is found on the left tab, just here. So clicking on this tab will open a custom reporting page where you can see different things. And what those things are, first of all, you have your default report templates. Here you can choose to create a completely empty report, basically starting from scratch. You see the 4 default templates we provide out of the box. So it's installation report template, predictive design report template, troubleshooting report template, as well as validation report template. I will cover them briefly soon. And in addition, you can create and save any custom report templates and also share those with your peers. So, hey, let's create our first custom report from scratch. Let's click here, and I have a completely empty section. So how do I configure my custom report? First of all, let's start from the left side, top left corner. And here I see the basic parameters for the report. First of all, report template name, reporter name, etc., date. Now, importantly, you can now choose the format you want the report to be outputted to. So you can choose between PDF and editable docx. So some people want to edit their reports after they're generated, and now you can do that with the docx export. In addition, you can choose any language, and that report will be generated in that language. So pretty neat, right? Okay, so that's basic settings. So now let's comprise our report. Here below, you can see different types of components you can add to your report. For example, you can have a cover page. You can drag it to the middle, and here it goes. Maybe we can also add some interesting components like our maps. That's usually the most important component of the report, at least more visually appealing, right? And then finally, let's have maybe a bill of materials. So now we have pretty much defined a very narrow, but still a structure for our report. And if you wonder why here the floor map went into this content repeater component, it means that the content within this content repeater will be repeated for each floor within your project. For example, I can drag this bill of materials to this content repeater report, and bill of materials will be generated for each floor of my design. Okay, pretty neat. So what happens next? Next, you can select each of the components and you can configure them to your liking. For example, cover page, we have some default background images, some default logo. You can remove those and choose a picture of your liking. For example, here I have some sample picture, and here it goes. And you can also configure whether the text will be dark or light. If it's a dark picture, maybe it's better to use light text on top of it. Now to the interesting component, floor map. What can you do? So we allow a lot of configurations now in AI Pro Online. So for the floor map component, you can choose which types of devices you want to see there. For example, do you want to see simulated, measured, or the original survey devices? Do you want which visualization you want to see, or whether you do not want to have any visualization on the map. In addition, you can choose the bands you want to include, all bands, or you can choose just 2.4, or you can use even multi-select. Just select multiple items from the list, and the drop-down will allow you to select only those items. So pretty handy if you don't have 6 gigahertz, or for example, you don't want to have 2.4 gigahertz in your report, right? All right. So in addition, what you can do, you can define the client height at which the heat maps will be calculated. By default, it's 1 meter, and also set an offset to your heat maps. For example, if by default it has 0 offset, but if you are planning for mobile devices and that perspective, you can choose that one as well. In addition, if you want to avoid clutter within your maps, you can exclude some of the elements. For example, if you don't want to have areas or walls or whatever other things, you can exclude or include them in the selection here. All right, so we have configured our components. Let's now generate our first report. So just click Generate Report button, and no capes. It should not take too long. And one beautiful thing is that while the report is being generated, you can actually edit anything in your design, and the report will still be generated on the background. And now it's ready. Let me open my downloads folder, and I think it is downloaded here. So one of the example reports I like to use is not the not the report I shown, but actually the bigger report where we have more data. So for example, this report has been generated earlier, and it has more information. For example, troubleshooting template allows you to show first the original data of your design, right? So even if you have made any changes, you have moved APs, changed the configurations, this report template will introduce you to the to the original set of data. And at the end of the plan or the report, you will have again the changes that you have made. For example, here, if I scroll down a bit, I will see now that this picture has already, let me zoom in a bit. This picture already has all the changes. For example, you can see the arrow that the AP has moved here, and also there are additional APs on the map. So this report templates allow for a lot of flexibility, and you can configure basically whatever you like in the using this report templates. All right, so that covers pretty much the first part of the demo. But maybe next we can check something else. Maybe we can move on to discussing how different report templates are used for different Ds in the 4D model, right? So let's go back to the report page. And here, the installation report is very narrow. If we open this template, it includes only the things that are needed for the installation crew to put the devices in their right places. So it doesn't have any heat maps, it just has an empty heat map with the AP location, and there is a bill of materials at the end, so you know which devices and how many there are and where to put them, right? On the other hand, if you are not using measured data, so we are still in the basically design phase, it is very good to use the predictive design report. It assumes that you don't have any survey data, you have just walls and the simulated design in your file, and that will basically output the predictive design with all the heat maps and the bill of materials, so you can send it for approval to your client or whoever needs this report. So no measured data needed, only the predictive data is required. Then, if we move to the troubleshooting report, this is the most interesting one. Here I showed you already a sample of the predictive design report, where we first show the original survey data and the problems or potential problems that there are within the design. And also at the end, we show how you can resolve those problems by showing the changes you made to your project. Validation report is a shorter version of troubleshooting report. It is using measured data, but it doesn't show the changes. It just shows you the results from your survey. So those 4 templates are very interesting, or might be interesting while you're implementing this for the approach. Okay, so time is ticking, and the final part of the demo is about the custom templates. So maybe you noticed that I clicked a save button when I was editing the template, and you can make any changes to the templates, the structure, background images, and you can save them, right? For later use, or you can also share those templates with your peers. It happens from the 3-dot menu. You just click here, you click share, and it will open the very same dialog you use for project sharing, so you can give edit rights, view rights, or full rights to your peers. And they can modify or contribute to that template and also use that in their projects, right? I have an example where Troy has shared a template with me. I don't know, are you promoting this some coffee brand? I'm not sure. But anyway, I have a template from Troy, and you can see that it has been shared with me. And if I don't want to have this template as part of my custom template set, I can always remove the access, and basically it will not delete the template from Troy, but it will remove it from my view. So hopefully
Vlad,
this demo, yeah.
Can I ask you a quick question around the sharing of the template report, so and how it works? So let's say that you have a report where you've built out your custom information inside of it that you're happy with. Troy's seen your report, got jealous, and thought, oh, you know what, I wanna have access to that. So you share that with Troy. So you both now have access to that custom template report that you can see here. If Troy then goes ahead and makes some changes to that report, what happens to the report? Does it get updated just for him? Does it get updated for you and him? Or what's the process there?
Yes, very relevant question. So when I have shared a report with Troy, for example, with full access, Troy can make changes to that report. And when he saves those changes, I will immediately see them and can implement those changes by using these templates in any of my projects. So it's synced while Troy is saving his changes to myself. Yeah.
Perfect. Thank you very much, Vlad. I can see there's been quite a lot of questions in the Q&A, especially around AI Pro Online, so and some of the custom report stuff. But before we answer that, I think Troy, you just wanted to promote something that's coming up quite soon. So let me just bring this up for a second.
Yeah, so on Tuesday, July 29th, we'll be having a webinar where we'll be having a panel discussion talking about Wi-Fi 7, uh, the evolution of it, how it can be used as part of the industry, drivers for consumers in the residential enterprise market. But as part of that panel, we have representation from some big players in the industry. So Charter Communications will be there, Google Fiber, as well as members from the Wi-Fi Alliance, as well as the Wireless Broadband Alliance. Right. So we have Kevin and Bruno from those 2 organizations. So you can register by clicking on the QR code there and check that out. And if you're not able to join at that time, registering will give you access where we'll send you an email so you can watch the recording at a later time that's more convenient for you.
Perfect. Thank you very much, Troy. That sounds like it's going to be a action-packed webinar full of some great guests. That's going to be a good one. I can't wait for that. Vlad, so a couple of questions around AI Pro Online. So not this one isn't necessarily related to the reporting, but someone did ask that will the online version only open surveys done on a certain firmware version, or can you open old surveys in AI Pro Online as well?
You should try it out, right? That's the answer. But yes, it should open them. Yes.
Okay, perfect. Well, Stu and Dale, if you'd like to come back, so I know that you guys have been answering lots of questions in the chat whilst you're returning. Someone asked a question about is there any useful prep work that you can do prior to enrolling in the ECSE design? So, Ryan, what I would say is that even just being on the webinars is a great way to prepare for the ECSE courses because we try and give a little bit of an insight and some training in this like 1 hour snippet that we do on the webinars. So that will give you a bit of a taste for what will be coming in the training. But also, if you're quite new and not so familiar with Ekahau products and Wi-Fi, we do actually have some free online video on demand training that you can find on the Ekahau website. So you could go ahead and watch some of those videos to give you a bit more of a head start before you get into the ECSE design course. Dale, you want to ask any questions, my friend?
Yeah, so one question that was asked was, or is, how does the transition from Wi-Fi 5 to Wi-Fi 6, 6E change the design approach in terms of channel planning, capacity handling, and client distribution?
That is a great question. Maybe me and Troy can tackle parts of that each. So what I think is a great thing to take into consideration if you are evolving your technology from Wi-Fi 5 to a newer generation model access point that supports Wi-Fi 6, Wi-Fi 6E, and Wi-Fi 7, especially if you're adopting the access points that support the 6 gigahertz frequency band, that automatically means that same access point that you had before in that same environment will be able to provide even more capacity because we can now leverage an additional frequency band to offload some of those client devices onto. So even if you have older devices in your environment that will be connecting to Wi-Fi that you can't upgrade, that only operate on 2.4 and 5 gigahertz, well, as the newer devices come in and you can get them onto 6 gigahertz, moving them out of the 2.4 and 5 gigahertz frequency lane to the 6 gigahertz one actually improves the capacity connectivity for your older devices because there's less congestion on those frequency bands. And then, Troy, is there any big considerations to think about if you're going from a 2.4 and 5 gigahertz, maybe Wi-Fi 5 capable access points to transitioning to 6 gigahertz and Wi-Fi 7 access points?
Yeah, so one of it, part of it's being mindful of the client transition. How many of your client devices are adopting Wi-Fi 7 technology? How fast they're being refreshed, right? If it's going to take 6 months before a significant number of your client devices adopt Wi-Fi 7, I would aggressively be looking at Wi-Fi 7 as part of my network infrastructure. But if my client refresh is, 5, 6 years out, maybe I wait till the next technology refresh to jump on the Wi-Fi 7 bandwidth. But that's a personal decision for your organization. With respect to coverage, I don't find a significant difference between the coverage on 5 versus 6 gigahertz. So if you have a well-designed 5 gigahertz network and you have good 5 gigahertz coverage, it's not significantly different for your 6 gigahertz AP placement. But the rub to that is that the client side coverage, the signal propagation, is significantly different. So depending on your regulatory domain, your client devices may have to transmit 9 dB lower than what your APs are capable of. Right. So essentially, you have the situation that Matt was describing earlier about access points shouting at the clients and then the clients whispering back. Right. So APs may provide a good coverage model, but as part of your design process, you want to make sure that you have good coverage so that when the clients talk back, they're still getting good signals heard by all of your access points. So that is a significant change in the way that we've typically designed Wi-Fi. Instead of just looking at APs out, we need to start thinking clients back to the access points and factor that into our designs.
Yeah, great answer and great question. And I can see there was a question in the chat that Jacob has also flagged for us as well. And I think what we've kind of just touched on there does cover this in some sense. But the question is that how do you model and future-proof a Wi-Fi network design to accommodate 3 to 5 years of projected client density, protocol evolution, like Wi-Fi 7 and application QoS demands without overbuilding? Well, I could recommend some software that could help you with that actually. So Ekahau AI Pro Online, you can model your environment, you can put in all your materials, you can model it in 3D, you can draw your areas, and you can nest multiple areas inside of an area. And the nice thing that you can do about that is you can do capacity planning. So you can place all your access points, you can put in Wi-Fi 7 cable access points to support the 6 gigahertz frequency band. You can ensure that you're providing not just sufficient coverage, but also for what you've configured for your areas with the capacity for what you want to support now on the network. Does it support those requirements? And if you think there's going to be an uptake, an increase in demand on the amount of devices you're going to have on the network, you can then put in those additional client devices and see if your network is still going to support it as well. So you can use tools like Ekahau, AI Pro Online to model this out and see not only do you get great coverage from your access points, but are they going to be able to support the client devices that you want to use in your environment as well? And we cover all of this in our training as well. So going into the theory of how many devices should you be planning for to support your network and what type of applications they're going to need to do. So that is a great way to kind of learn a little bit more about that. Stu, what have you got on your jumper?
Well, I saw in those reports that we had a number of different multi-languages that we could translate our reports into, but there was definitely one language that was completely, I think, not there. And having Grand Moff status, I think that maybe we might want to put Arbesh in there. I think that might actually would resonate. What do you think, Troy?
It would certainly help for some of the audience that would be consuming our documents, not for everybody. But as I mentioned, the goal of all your reports that you generate, you want to tune and tweak them for whoever's going to be consuming them. So if that's what helps communicate your message for your design or your recommendations for troubleshooting your network, then it's something we want to make sure is included.
Right? Especially for our clients and customers in a far-off galaxy.
Mhm. Hey, why don't we take one or two more questions from the Q&A or the chat before we wrap up the webinar today? So Dale or Stu, have you got any ones that you wanted to get us to answer before we wrap up today?
I think there was one here actually that we kind of did cover here, and it is talking about that the and I think you're going to cover this in another webinar as well, Troy. Is that kind of a good segue into Wi-Fi 7 planning? And the question was, do I have to? Is there any other different design considerations today because they're going between frequencies, or should we just make sure that we're looking at the basics, right, of Wi-Fi planning?
Yeah, so as part of Wi-Fi planning, I like to leverage Ekahau as kind of a proof of concept, right? So when I run my channel planner, automatically assign channels to all my radios, I'm validating that there's a solution that minimizes co-channel interference, right? And then I have the option, as Matt kind of described earlier, I could take that plan and I could manually configure that in my vendor's platform. I could leverage some Python scripts. I could let AutoRef take care of it, but I want to match whatever my configuration was in Ekahau. If I had to exclude channels or I constrained my channel width, I want to make sure I match that configuration in my deployed wireless solution so that I get similar results. If it was failing in Ekahau, it's going to fail in my AutoRef protocol, right? So I'm just validating that I have a successful configuration, and I'm not going to create those co-channel interference scenarios.
Perfect. Dale, was there any other question you wanted to get us to answer before we wrap up?
Yeah, sure. So there's this one I did answer, but I'll ask you guys for some of your perspective as well. But for secondary signal strength, should it have similar coverage to the primary signal strength, or is there some strategic way to design it? Now, what I said is how I've done it in the past is um you take a look at your LCMI, least capable, most important device. And oftentimes the vendor or manufacturer will have some best practices documentation that will specify some of these values that you could then feed into your requirements when doing your predicted design. But any insights or perspective outside of that or similar on your part?
So for
I
secondary coverage, it's required when you're considering three different factors, right? So roaming, redundancy, and capacity, right? So it could be a mix of all three of those or one or two of those, but understanding that helps guide you on what threshold you should be looking at for secondary coverage, right? So if I'm just looking for hardware failure, as an example, if one AP dies, I will need overlapping signal from another AP to buy me some time until I can RMA and replace that AP on a ceiling. Now, in that failure situation, do I need to provide the identical Wi-Fi performance? And in that case, I probably do want the same primary and secondary thresholds to match my performance. But if I want to reduce the number of APs I deploy in my site, reduce the cost of that deployment, maybe I have 500 buildings across the country that I'm trying to deploy in. If I could reduce my AP count by 20%, maybe I have primary set to NIC 67 and secondary set to NIC 72. So that Wi-Fi still works in a failure condition, it's just not as fast. And if I have an RMA where I get 24-hour turnaround, I'm only at compromised performance for a 24-hour window, right? If we're looking at designing for roaming, right? So for voice latency sensitive applications, that's where we want very strong signal overlap. And you probably want to design for matching primary and secondary in those scenarios so that there's enough overlap and walk out a range of one access point, you'll hear the second access point or the second radio in time so that you can make successful roam before you walk out a range of the first access point. Good resources to look at are best practice vendor design guides for your particular client device or your particular wireless manufacturer on what they recommend for primary and secondary coverage. As an example, Apple and Cisco have collaborated in a document where they recommend for iOS devices to work well on your network, they want matching primary and secondary signal strength at NIG 67, right? So in that example, they're both the same, but it depends on, again, your targets for secondary. Are you looking at roaming? Are you deploying this for redundancy purposes? Or are you deploying it for capacity where you have, a large auditorium or a meeting room and you've deployed multiple access points in that large open area to give you coverage and then try balance client devices across the numerous radios in that large open area.
Yeah, great way to answer that question, and I think your response also, Dale, was fantastic. One last thing, just to quickly mention, because someone put in the Q&A the same question that I was asking Vlad earlier before when we was talking about the online reporting functionality, being able to report, Vlad, not only your transmit power of your access points, but also being able to include the EIRP that you can see in AO Pro Online. Is that something that will be there or be there in the near future?
It will be there in the near future, yes.
Yeah, so we when you run the reports now, you'll be able to see the transmit power information, but you also, if you want to as well, be able to include like things like EIRP, get very granular with the things that you want to put into your report. You can save them as your own template, use that for the specific projects or specific types of work that you're doing for your Wi-Fi lifecycle, and also share them with your peers as well if you want to share them too. So I think that's a good way to end on the webinar today. Thank you so much, everyone, for joining us and everyone on the call today that helped put the webinar together. And we'll look forward to seeing you on the next one.